Hello everyone and welcome to Instant Biology by Dr. Neelab. The topic that we would be dealing today is bioprocess engineering, and this would be the second lecture on bioprocess engineering lecture series. And you all might be knowing that we have completed the lecture series in Hindi on bioprocess engineering itself, but we have started this lecture series in English, so as to help the students who do not understand Hindi and also prepare them for the GATE examinations. So without much ado, let us start this lecture. In this lecture, okay, first of all let me brief you about the last lecture that we did. In the last lecture we had discussed about what are the basic processes like batch culture and continuous culture, semi-batch culture, fed batch culture. We have already talked about that. Furthermore, we also discussed about the closed and the open type of systems, right? So keeping that in mind, we would now move on to the second lecture of bioprocess engineering lecture series. In this lecture we would be dealing with steady state concept and equilibrium concept. See, these are the two very important concepts on which the future lectures would be based, on which the future discussions would be based. So I would request you to kindly watch this lecture till the end, so that you may not have any problems in understanding the future lectures. So let us start. What is steady state? So you might be knowing that whenever a reaction takes place, whenever a biological or let's say a physical process, a chemical process, whenever it takes place, what happens is there are multiple parameters that are present in the reaction, like temperature is present, volume is present, mass is present, pressure is present, etc., etc. So the point I want to make over here is that number of parameters are associated with the reaction. Okay, whenever these parameters do not change, let me write it down. Whenever these parameters do not vary or change with respect to time. So as the time progresses, these parameters do not change, they remain same, then this particular reaction would be called in a steady state. Okay, this reaction would be considered to be in steady state. Again, let us understand this. Whenever the parameters of a reaction like temperature, like pressure, like volume, etc. and etc. are not changing, are not varying with respect to time, then this type of reaction, then this particular reaction would be considered to be in steady state. So okay, so this is the first concept that I wanted to focus upon. Now let us move on to equilibrium. Now what is equilibrium? Let us consider this. In chemistry you might have again read about equilibrium. Equilibrium is a state in which both the forces, the opposing forces, balance each other. Okay, the opposing forces balance each other. Let us consider, or let us understand this with the help of an example. Okay, let us say that this A is converting into B. Okay, let us say that this A is converting into B, and this is happening at equilibrium constant K equilibrium. Now you might be knowing that K equilibrium would be equal to B divided by A. That means the concentration of B divided by the concentration of A. This would be the value of K equilibrium. So what I mean to say is that a reaction is in equilibrium when do we consider the reaction to be in equilibrium? When the rates of the forward reaction is equal to the rate of the backward reaction. This means that both the rates of the forward as well as the rate of the backward reaction is the same. Please do not confuse. Many students confuse with the concentration of both products and reactants. I am not saying that the concentration of product would be equal to the concentration of reactant, or otherwise the concentration of reactant equals the concentration of product. I am not saying that. What I am saying is that the ratio of the formation of product and reactant would be same, would be constant, which means in other words that the rate at which the product is formed is the same rate at which the reactant would be formed. This is what I am saying. So let us consider this at equilibrium. Equilibrium can be considered as a special case of steady state. So in steady state we said that all the parameters won't change with respect to time. In equilibrium, what are we saying is that both the forces of the reaction, the opposing reactions, would balance each other, and the rate at which the reactants were formed would be equal to the rate at which the product is formed. Now let us we can also understand, or we can also link the K equilibrium with delta G concept, and also understand that whether the reaction would move forward or would move backward or would be in equilibrium only. Let us understand this also. See, when I am saying that let us just understand this equation again. I am saying that A is the reactant and it is forming B, which is the product, and the equilibrium constant of this reaction is K equilibrium. Now K equilibrium, I am saying that it would be equals to the concentration of B divided by concentration of A. So now here we can understand three cases, right? So in first case what we can say is, in first case we can say, let us say that the value of K equilibrium is greater than 1. Let us say that the value of K equilibrium is greater than 1. Now this would indicate that, let us see that this would indicate that the product is formed more as compared to the reactant. Okay, so now you can say that what is happening is the forward reaction is being favored more. So K equilibrium is greater than 1 would symbolize that delta G is equals to negative and the reaction is spontaneous. The reaction is spontaneous. See, from only the K equilibrium value I can understand these points. Next point what I can say is, when K equilibrium is less than 1, then delta G would be positive and the reaction would be non-spontaneous. Why am I saying that? Because here in this case, how will the K equilibrium be less than 1? It would be less than 1 simply because the A value or the reactant value would be more than the product value, concentration. Okay, so in this case K equilibrium will be less than 1, and in this case delta G would be positive. For those of you who do not know delta G is the Gibbs free energy. So delta G would be positive and the reaction would be non-spontaneous. That means you will have to put in some extra energy from outside in order for the reaction to happen, right? So in the third case, let us consider this, that K equilibrium is equals to 1. K equilibrium is equals to 1. This means that the reaction would be constant. It won't move forward or either it won't move backward, it would remain constant. Okay, so this would be K equilibrium is equals to 1. So this was all about the equilibrium, and in case of equilibrium you have to remember that it is a special case of steady state. So whenever a reaction is in equilibrium, you can always say that it would be in steady state, because equilibrium is a part of steady state, right? It is a special case of steady state. So whenever a reaction is in equilibrium, you can always say that it will be in steady state, but not vice versa. If a reaction is in steady state, you cannot always say that the reaction would be in equilibrium. So this is a very important point. Now let us understand what is unsteady state. Very simple. Whenever the whenever these parameters, let us say temperature, volume, mass, pressure, these are changing with respect to time, you can clearly say that the reaction is in unsteady state. The reaction is in unsteady state. So this is what I meant by unsteady state. Now let us come to the law of conservation of mass. So why am I talking about law of conservation of mass? Because from here I want to start with the material balance. So you cannot understand material balance until and unless you are not able to follow the law of conservation of mass. First of all, we have to understand this. So the general equation of mass balance, how can you understand the general equation of the mass balance? Let us first of all learn about this, that let us talk about a fermenter that you are using. Okay, you are putting in some mass. What mass you are putting in? Let us say that you are putting in the nutrients for the bacteria to grow, then you are putting in the bacteria themselves, then you might be putting in some water or anything, vitamins or nutrients, whatever you are putting in, depending upon the equation, depending upon the process that you want to do, you will put in your mass. Okay, so this is the mass in, or what mass you have put inside the fermenter. Now this, whenever you subtract the mass out, that means suppose I'm talking about a continuous fermenter over here, I would be taking out the mass from the fermenter continuously. So this would be the mass out. Now this is mass generated. Now let us understand that some or the other mass would be generated. What does mass generated means? See, the cells would be present inside the fermenter. They would start consuming the nutrients, and they would start expanding their size also, and they would also start to multiply. This is what you have to understand. They will multiply also, they will increase their size also. So there, all in all, what is happening is their biomass is increasing. This is what I want to say. So here mass is being generated. Next, mass consumed minus mass consumed. So mass consumed, what does mass consumed means? The cell would grow in size, or the cell would increase its biomass only by consuming the nutrients that you put inside the fermenter. So what will happen here? What will happen here is you subtract mass consumed. So what are we doing over here is this mass in, you have this is with the plus sign, mass generated is with a plus sign, and mass out and mass consumed are with a negative sign. What would it lead to? It would lead to mass accumulated. This you can understand is the mass or the nutrients that has been converted into biomass. You would get the value over here, that would be the mass accumulated. So mass accumulated equals to mass in minus mass out plus mass generated minus mass consumed. So this is a general equation. See, your equation can be modified with the process that you are doing. I'll just give you an example in a few minutes that how can this be modified, but this is the general equation. You can always use this equation and do whatever and use it according to your this reaction, right? So let us move forward and understand that what all is conserved inside a reaction. Let us understand this. So when I am talking about the conserved things, total mass is conserved and number of atoms of each element remains conserved. So total mass, what does total mass means? See, I am saying that mass in minus mass out plus mass generated, this should be equal to mass accumulated, right? Because mass can neither be created nor destroyed, it would remain the same. It might be changed. Let us say you were using the nutrient media first, now it has converted into biomass. It can simply be changed like this, but otherwise there would be no change, right? So total mass would be equal. I mean, it should be conserved. If you do not find this equal, these values equal, then there is some or the other error, or your machine is not working properly, right? So total mass should be balanced, and the other thing that I want to say over here is the number of atoms of each element would also be balanced. This would come under the element balance. But let us say that the most important elements that I used in the bioprocess engineering are C, H and O. So now C, let us say that let us say about the terms that are present on the left side of the equal to. So the C, H and O, that should be equal, or the number of atoms of carbon should be equal to the number of atoms of the product. That is what I'm focusing on over here. So I'll take another lecture on this elemental balance and explain it to you in much more detail there. But what you have to learn over here is that the number of atoms of each element would be conserved. Okay, now let us move forward and take a specific example. I said that this particular mass balance equation can be changed according to your wish and will, and according to the reaction that you want to move forward with, right? Suppose there is a sugar plant, okay, suppose there is a sugar plant. Now what is happening in sugar plant? What do you do is produce sugar with the help of a sugar cane, plants. So what do you do is, this is the modified equation for the mass balance. What you are doing is, you are putting in the raw material, that means you are putting in the sugar canes and all, and with the help of sugar canes what you are doing is, your aim is to form the sugar. So raw material would be equal to the product, that means the sugar, plus waste product. There would be some or the other, I mean the plant things that would be considered as waste. So this would be waste product, plus this would be the stored product. There might be some sugar entities that would be present inside the fermenter, that is the stored product. And finally the losses. There might be some charring of the sugar that can happen. The sugar might have got burnt or might have got changed into vapor or gases. So that would be considered in the losses. So if this complete thing is coming equal, I mean the raw material that you had put inside is equal to this particular process, then you can consider that your machinery is working properly. Otherwise you have some or the other error that you have to address. Okay, so this was an example of the sugar plant. You can take any example, okay, but for that particular example your this mass balance equation might change. Okay, now let us talk about the component balance. So what I'm talking about in this particular component balance is, let us take an example that suppose I want to balance the amount of a protein or amount of a lipid that is being formed. So what I have to do is, I would be providing some of the other component of the protein that would be considered as input. Some of the protein might be obtained in the output. Some of the protein might be formed by the cells, and some of the protein might get disappeared. That means the cells would have intaken it, or it would be present inside the biomass of the cell. So this can be considered, or this would be equal to the accumulation. This would be equal to the accumulation. So what we are doing is, we are taking a particular protein, we are considering a particular protein, we are considering a particular lipid. When we are considering a particular entity, then it would be called as a component balance, because we are just balancing that component and nothing else. This would be called as a component balance. Now let us talk about the types of mass balance. So in the Hindi lecture, many students inquired about this, so we can understand this in a better way over here. Types of mass balances. So let us consider this, that there can be two types of mass balance. First one is differential balance, second is integral balance. Okay, so let us take the example of differential balance. So in differential balance, what happens is, the best example of differential balance is the continuous culture. Okay, so you are aware that when the rate of flow, when the rate of inflow is equal to the rate of outflow, the continuous process can go on till infinity. But you are aware that we are, I mean, in the continuous process, what are we dealing with? We are dealing with the rate of inflow, the rate of outflow. So you are aware that rate can be considered as dx by dt. How is rate mentioned? It is always mentioned like dx by dt. What is dx? It can be the utilization of the nutrients. Okay, it can be biomass, it can be anything, whatever you are trying to mention over here. So in differential balance, what we are saying is, in continuous cultures, the readings are taken for a particular instant, right? Suppose I am interested in taking the readings of a continuous culture, then what will I do? I'll just go at a particular instant and take the readings. That is more than enough in case of continuous cultures. In case of continuous as well as batch cultures, not that much in batch cultures, but yes, in continuous cultures, you can take the readings at a particular instant. Why? Because we are dealing with the rate, and the rates are differential in nature. Right? See, this is the differential equation, right? dx by dt is differential. That is why it is called as differential balance. Now let us consider integral balance. So in integral balance, what you have to do is, suppose we are doing an experiment in the batch culture. So you are aware that when you are doing an experiment in batch culture, what you are doing is you are putting in the entire media and inoculum and then packing it for a period of let us say 1 and 1.5 months. Whatever is your protocol, you are doing it and then you are packing it, and then you come after 1.5 months, whatever time, and then you take out your product. So whenever you are trying to monitor the batch culture, what you do is you have to take in the readings multiple times. Okay, you have to take in the readings multiple times, many times. Therefore it cannot be taken at a particular instant, but it has to be taken multiple times. That is why it is called as integral balance. Integral means joining or taking it multiple times, or then taking it multiple times and considering the whole of it together. So that is why in case of batch culture, you do the integral balance. Now coming to mass balance in steady and unsteady state. So now with this discussion, you would be aware that the continuous process is the only in general process which can be present in the steady state. Why am I saying so? Because in steady state only we said that these parameters won't change. Okay, so in continuous process, what is happening is you are putting in your media, you are putting in your material, and then you are removing it. Okay, so there is a chance that these temperature, volume, mass and pressure won't change. So this can happen only in the steady state. But let us consider a batch process. In batch process, what is happening? You pack the entire stuff and then you leave. Let us say the reaction is exothermic. What it will do is it will heat up. That is what I wanted to say in unsteady state. So these are unsteady state. The examples are batch culture, fed batch culture. These are unsteady states. Why these reactions are in unsteady state? Why? Because let us take an example that suppose you packed the entire thing and then you left. What is happening? The reaction is exothermic. What will happen is the reaction, the temperature of the reaction would increase, but you are doing nothing to lower down the temperature. So again, the parameter of temperature, you are letting it change. Therefore it would be in the unsteady state. So this was the discussion about steady state, equilibrium, unsteady state, law of conservation of mass, component balance, types of mass balances, and steady and unsteady state. I hope that this lecture would be clear to you. One thing more, that the third batch of the June batch of the Introduction to Bioinformatics course is running. I would request all of you who want to enroll or who want to learn bioinformatics with us, because it is an important component of the GATE examinations. So if you want to learn the Introduction to Bioinformatics with us, it is a great course. And if you want to learn with us, just message me on Telegram, or you can directly message me in the comment box of this video and I'll get back to you. So I request you to like this video, subscribe to my channel, and also circulate these videos so that people who need it may get benefited from it. Thank you. Have a great day.